I would encourage you, once you've got this data frame, so we've got PitchDF, and I would encourage you to play around with, again, I'll type my dot and then look at the member functions. So we've got add, we've got align, we've got append. You've got a lot of things you can do with a data frame once you've built it up. And again, you can read these in from CSV files. So, you know, we're doing this the hard way because we were given an XML file that we've had to pull in, but you can pull it in from CSV. But I would encourage you to play around with some of the methods that a data frame can do. One of them, you know, we talked about head. You can also do tail. And I'll execute a couple of these. So now we're looking at the last 5 rows. So we know that it goes to 257. We can do dtypes and run that. Okay, so we can look at the types, so we can see which of our fields are objects, in this case strings, and which are floats. So again, depending on the data that we put in, ended up designating for that column. We can do dot columns. And again, look at the structure of the database. And last one I'll show you here is we can do a describe. And again, see more of the details of the data in our database. So with that, let's make a plot. Let's throw something on the screen here. That was the whole goal here. We've been a long time getting there, so let's get something to throw up on the screen. I'm going to say that lines equal PitchDF.plot. So we've got a built-in function on a data frame called plot, and we're going to produce a line plot where we say x is the pitch index, and that's a string, and our y is the speed. So in other words, let's just look at, and again, I'm not filtering top or bottom. I'm not filtering anything at this point. Just looking at every row, and I'm going to say the figure size within our inline plotting here is, let's call it a 12 by 6. Okay, so that defines a line plot, and if we execute that, what you'll see is here's the speed, and it's the pitch by pitch. So we started out the game with about a 94 pitch, and we haven't plotted out whether that's a fastball. Obviously we know it is a fastball, but here's the up and down of the pitch, so you see kind of the rhythm of that. So while that plot is the rhythm of the game, it also includes the Colorado pitches, and there's really no distinction on where they stop and start. So let's do this. Let's say that color, let's change the plot a little bit, and we'll say color equals green if f equals top. So let's use green dots for the top of the inning, else yellow. And where did we get that f? It's for f in our data frame, and here's where we use filters. So data frame under frame, and we'll want to output that as a list, to list. And so that'll set a color, and now what we're going to do is we're going to do a different plot, and this time we'll say the kind equals scatter, and our x coordinate to plot is pitch index, and y equals speed. So once again, we're plotting speed, but we're going to differentiate, and our color equals color, which we set above. And once again, the figure size will be 12 by 6. So let's try to plot that. And we get key error IDX, so looks like that needs to be a capital I. Pitch IDX, we'll run that. Okay, so here's our problem. The error is scatter requires X column to be numeric. So clearly it doesn't believe that our X column, which is pitch IDX, is a numeric value. We're trying to plot it against speed, so it needs both of those to be numeric. So let's do this. Let's insert a column, or insert a cell above where we're at. And let's just ask it pitch df, our pitch data frame.info. Let's find out what it believes that to be. We'll run that, and sure enough, there's pitch IDX, and it says it's an object, no different than our string columns. And it got correctly the speed, the PX, PZ, and the strike zone. So we cast those into floats. It knows they're floats. And what we'll need to do now is take the pitch df column, which is pitch IDX, and we'll assign it to that same column with the NumPy cast as type, and we'll cast it as an int. Now, I'll show you something before we do. It's a common error. If I take that off and I run this cell, and we made the cast, and now I'll run it again to make sure the info shows us that cast. And you'll notice that it still sees pitch IDX as an object. And the reason is, if I put this back, we need to reassign. We need to take that data frame column and we need to reassign it. Because this AS type, this typecasting, returns a column, but in the first place we didn't reassign it. So now if we do, now we'll have to run this twice. Well, let's do this. Let's just take this out and let's put it afterwards. So here we're making the pitch IDX column a type integer, and then we're asking for info. And at that point you see pitch IDX is now an int 32, and now again those values are now in place. That run as cell 90. This last ran as 89, but if we run it again, now we get the scatter plot. So there's what we were after. Now what you'll notice here is we've got Kershaw's pitches, basically the Dodger pitches, which is all Kershaw. We've got those in green, and you see that he's jumping from mid-90s all the way down to 75. And you notice the pattern of the Colorado Rockies pitchers. Much more tight, going from somewhere around 83 to 94. And that is true until we get to this. This looks to me, this area here looks like a pitching change. Looks like this pitcher is throwing with more range, or at least more speed. Now, I'm not representing that this is incredibly useful graph. Really what I'm trying to show is that we have, by putting our data in a data frame, we've gained the ability to have that data frame itself do plots and to control the different output of that plot. So let's move on and let's get to plotting the strike zone. Let's use this PXPZ and the strike zone top and bottom to get visual about where Kershaw's pitches were thrown.